Today you will be solving systems with 3 variables. So your ultimate goal when you're solving a system with 3 variables, we want to manipulate it so we can use back substitution. So if you look at the first bubble, notice we have three equations. And notice the top equation has 3 variables, the middle equation has 2 variables, and the third equation has 1 variable. Notice it does have a stair-step-like pattern, and the leading coefficients are 1. The leading coefficients are 1 isn't really that relevant, but the number of variables in each of the equations is. So you want to have one with 3, one with 2, and one with 1. When you go to pre-calculus, they will talk more about this row echelon form. So if we look at our first example, it says we're going to solve the following system. So if we look at this system, notice that we have an equation that has 3 unknowns, the middle equation has 2 unknowns, and the third equation has 1 unknown. So we can use our back substitution. So first thing I'm going to do is I'm going to put z equals 2 into equation 2. So we'll have y plus 3 times 2 equals 5. And then we solve the equation y plus 6 equals 5, or y equals -1. Now we have z and y, we can plug those variables into equation 1 to find x. So we'll have x minus 2 times. So note we're going to replace the y with a -1, and then plus 3 times our z value, which is 2, is going to equal 9. And we just do our order of operations. So x plus 2 plus 6 equals 9. X plus 8 equals 9. And when we subtract 8, we do get x to equal 1. And just like with 2 variable systems, what we will do here is we will write our solution as an ordered triple. So our x value, then our y value, and then our z value. And that's it. If we look at our next definition, we write our solution as an ordered triple. Note you're going to put it as x, y, z, or in alphabetical order. So let's talk about elimination with 3 unknowns. Well, each of the following row operations of a system of linear equations produces an equivalent or an equal system of linear equations. If I wanted to, I could interchange the position of 2 equations. I can multiply one of the equations by a non-zero constant, and I can add a multiple of one of the equations to another equation to replace the latter equation. Okay, so what that means is I can multiply one of my equations by some constant and then add it with another equation. So if I take equation 1 and add it with equation 2, the addition replaces equation 2. Let's look at an example. Let's say we wanted to solve this system. The first thing I would do is I would look at the variables and see if there's one that's probably the easiest to manipulate. Okay, if it were me, I noticed right away that these z's would be easy for me to manipulate because I only need to multiply equation 2 by positive 2. So that's what I would do first. So I'm going to multiply equation 2 by positive 2. So we'll have 6x plus 6y plus 4z equals -6. And we didn't do anything with equation 1. So I'm just going to recopy equation 1 directly above its corresponding variables. And now we're going to add the equations together. We know 5 plus 6 is 11x. -2y plus 6y is 4y. And the z's cancel, equals -3. Now this is that example where we multiplied one of the equations by a constant and added 2 equations together. This replaces equation 2. So I like to write new equation 2 underneath it. And now the next step is to rewrite our system. So equation 1 and equation 3 remain the same. That's an equal sign. Remember, I'm going to take the new equation 2 and put it in the position of equation 2. So equation 2 is now 11x plus 4y equals negative 3. Now, if I got rid of z in equation 2, I need to get rid of z in either equation 1 or equation 3. Okay, if I don't do that, I'm going to put z back into our system, and it makes it challenging. So the common multiple of negative 4 and 3 is 12, so we'll multiply equation 1 by 3. So we'll have 15x minus 6y minus 12z equals 9. And equation 3 we'll multiply by 4. So we'll have negative 8x plus 20y plus 12z equals 12. And now we're going to add the resulting equations together. 7x plus 14y equals 21. And because we added equations 1 and 3 together, this new equation is my new equation 3. Okay, so now when we rewrite our system, I'm going to take from the previous step equation 1, 5x minus 2y minus 4z equals 3, my green equation 2, so 11x plus 4y equals negative 3. In my new equation 3 that we just found, 7x plus 14y equals 21. Okay, so now we have to get rid of either x or y using equations 2 and 3. Now, it doesn't matter which one you get rid of. I would probably choose to get rid of y because they have a smaller least common multiple. And the common multiple of 4 and 14 is 28. So I would choose to multiply equation 2 by negative 7 to give us negative 77x minus 28y equals positive 21. And I would multiply equation 3 by positive 2. So we'll have 14x plus 28y equals 42. Now when we add our equations together, the y's cancel out, and negative 77 plus 14 is negative 63x equals positive 63, and this means that x equals negative 1. This is our new equation 3. So now we're going to rewrite our system. We're going to use the equations 1 and 2 from the previous step. So 5x minus 2y minus 4z equals 3. 11x plus 4y equals negative 3. And our new equation 3, which we just found, x to equal negative 11, or negative 1, sorry. Notice we have a system now with 3 unknowns, 2 unknowns, and 1 unknown. And so now we just use that back substitution component. So I'm going to replace the x in equation 2 with a negative 1. So we'll have 11 times negative 1 plus 4y equals negative 3. Okay, negative 11, let's see, 4y will equal 8. So y will equal 2. Okay, and now we plug x and y into equation 1 to find z. So let's see, we'll have 5 times negative 1 minus 2 times 2 minus 4z equals 3. Or negative 5 minus 4 minus 4z equals 3. Let's see, negative 5 minus 4 is negative 9, and then I add that to the other side. Negative 4z will equal 12, and z will equal negative 3. So now that we found our x, we found our y, and we found our z, all that's left for us to do is to write our solution as an ordered triple. Our final answer, negative 1, 2, and negative 3. Let's look at another example. So if we look at our system, we already have one equation with y completely eliminated. So we can do a couple different things here. We can either try to eliminate an x or a z and kind of see what happens from there. Let's eliminate a y. Why not? So the common multiple of 1 and 2 is 2. So I'm going to multiply equation 2 by negative 2 so that when we add down, the y's cancel out. So we'll have negative 2x minus 2y minus 2z equals 34. And equation 3 is going to remain the same. X plus 2y plus z equals 16. So we'll have negative x, y's cancel, minus z equals 50. Oh, I missed something. Oh, forgot my negative sign. Negative 18. And this is our new equation 3. So remember, we're going to rewrite our system. We're going to use old equation 1. We're going to use old equation 2. And new equation 3, which we found to be negative x minus z equals negative 18. Oh, I have another mistake. Have you found it? Guys, when I multiply negative 2 with 2, it should be negative 4z. Which means this is negative 3z. Okay, well, if we look at our system now, notice in equation 1 and equation 3, we just have x's and z's. And x's already have opposite signs and the same coefficient. So I like to write them out again so my paper is less cluttery and messy. So notice the x's will cancel and we'll have negative 2z equals negative 10. In this case, z is 5. And this becomes our new equation 3. Okay, so now we're going to rewrite our system. From the previous step, we'll use old equation 1, old equation 2, and our new equation 3, which we found to be z is equal to 5. All that's left for us to do now is to use that back substitution. So first I'm going to back solve into equation 1. So we'll have x plus 5 equals 8, or x equals 3. And now we'll take x and z and put into equation 2. 3 plus 5 plus 2z equals 17. Let's see, 8 plus 2z equals 17. Or where's my mistake? Oh, look at this. Oy, oy, oy. Did you see what I did? I've replaced the x with a 3, but I put the z equals 5 in for y instead of in for z. Whoops. Okay, so we'll have 13 plus y equals 17, or y equals 4. And remember to write your solution as an ordered triple. So our solution is 3, 4, 5. Now I want you to take a minute or two and try the example you tried. The solution you should get is x is 1, y is 4, and z is negative 3. And finally, you are ready for practice, except for the title is wrong here. Your title should be Solving Systems of Three Equations assignment. The end.